We've seen if statements. If some condition is true, do something. If you're hungry, eat. This doesn't have another side, so we're not going to do anything if we're not hungry. That's pretty boring, but that's the way this one's written. Then, if else. If it's raining, take an umbrella. Else, wear sunscreen. Whatever. You're going to do one of two things. Notice that there's no block for the word else. I've mentioned that before, I believe. People want to put an else in a diamond. So if you want, you can put the word else over on the nose side, but only if there's actually something to do. Because in the prior one, there was no else at all. You just write it if, and then you indent some code, and then you stop indenting, and that's it. To do an if-else, you do if, you indent some code, you stop indenting, then you put else. And then you indent and put some code and stop indenting. So it makes sense to me that people want to see the word else on there. You totally don't have to do that. You can just leave it saying yes or no. Some people like to put false and true on them. Then there's the if, elif, else. Now other languages actually use the words else if. Python abbreviated it elif. The way that works is a little bit different. I've said it before to y'all. I need to abide by it. Downloading the PDFs or the PowerPoints are much better than viewing them in the preview. So an if, elif, else is when you'd want to do more than two things. If the temperature is less than 32, print ice. Else if temperature is greater than 212, print boiling. Else, print liquid. We have three different mutually exclusive choices. If they're not mutually exclusive, you don't use elif. And what do I mean by that? If handsome, print good for you. If wealthy, print cool, buy a car. All right, now that's silly, right? But, I mean, these are not mutually exclusive conditions. You might be handsome and wealthy, especially if you're wealthy enough to afford lots of plastic surgery. So, those are not mutually exclusive. You would not use else ifs there. But there are times when you do, like this. If grade greater than 90, print A. If grade greater than 80, print B. If grade greater than 70, print C. And then we're going to throw in an else to handle anything lower than a C. That's one mean teacher. So, this isn't good code. Why? Because if your grade is above 90, you're going to make both an A and a B and a C. Is grade greater than 90? It sure is. Print A. Is grade greater than 80? Yeah, it sure is, because it was a 90, so print a B. Is it greater than 70? Yep. Now you could fix this by putting these in the opposite order. But it's better just to make them mutually exclusive. If you put else ifs, then if the grade is greater than 90, it prints an A and then jumps down to the end. All done. Else, it checks again. And it keeps checking until it finds a good condition. When it finds a good condition, it runs that code. If your grade wasn't greater than 80, but it is above 70, it prints out C and then jumps down to the bottom. So that's what the flowchart looks like. If this is true, do something. But if it's not true, check again. Do something. And if that's not true, do the default clause down at the very bottom. And then no matter what, don't go back and check the next case. I actually need to draw that, like the first one, if handsome and if wealthy, because it's two diamonds in a row, but after it prints handsome, it comes back here and does the next check. So I've left a page out of the cookbook here. The only difference between these two slides is the else on this one goes off to the left, and here the else goes off down, straight down. And like I've said before, it doesn't really matter which way the lines go as long as it makes sense to you and I can follow it. So maybe that makes it look cleaner, you know. I really would like to be able to always go off to the right whenever we indent the code, but that's not really super duper possible for this else one. I guess we could kind of sneak it over there, you know. Anyways, then the while loop. I know we've used whiles. We haven't talked too much about them. The way the while loop works, if this condition is true, it's like an if statement. Then go and do the tabbed stuff, but instead of just continuing straight down like an if statement does, loop back, check it again. And if this ever becomes false while it's looping, then stop going. The same structure is used for for loops. Now textbooks will document this differently, but this is the way that I want y'all to do it. Then there's one last one called a while true with a break. And I'm going to avoid using the break statement today. The break statement causes an early exit from the while loop. It doesn't wait until this condition becomes false. So one thing you can do is write while true and just make it loop forever, but then some condition breaks it out. Because if it doesn't have a false condition, otherwise it'll run forever. And I think Kathy asked about that last time. That's called an infinite loop if it has no way out.
I've never seen that before. We have a quick example.
Yeah, absolutely. Very good question. Thank you. And it's actually the way I like to implement a certain style of user input. So we are going to start using it. But for now, here's a example of a while loop without a break. While x is less than 10, print hello, and then increase x plus equals 1. I'm going to save this one and call it loopy. And if loopy's already used, maybe loopy too, I don't know. Loopy. Okay, so when this one runs, it doesn't need a break statement because it gets cleanly out of there. Now we're going to write an infinite loop. While, now I could write something that's just always true, no matter what, while x is equal to x. But that's stupid. If I wanted to be an infinite loop, I'm just going to say while true. Because the thing after the word while is a condition. And if that condition evaluates to true, it repeats. But if that condition is a word true, it'll repeat forever. So, while true, print goodbye. Now don't do anything. Alrighty. Now it's going to run forever. That's our infinite loop. Apparently this computer enjoys saying goodbye much more than it says hello. But we can use a break statement. Let's do some input. A is equal to input. Do it again. Y/n. And if A is equal to n colon break. So in general, it's going to keep looping. But if they ever type in an n, it's going to hit that break statement and that'll exit it from the loop. And so I'm going to print all done down here at the very bottom, just so that we know we escaped from the while loop. Okay, so that worked. That's an example of using a break in order to get out of a loop. Does that make sense? Now you don't have to, just because you're going to use a break doesn't mean you have to use while true. But if you start writing more complex logic where it could get out for that reason and it can also get out for another reason, then the code just starts getting a little bit too confusing. Now can you write this code so that it doesn't need a break? Yes, you can. We're going to write it one more way. We're going to do this. A is equal to yes, while A is not equal to no, or while A is equal to yes, we could do either one. Then print was up. And then we're going to ask if they want to do it again. A is equal to input. Do it again. Y/in. Now that looks pretty good. It's shorter. Maybe the logic is cleaner. There are times when I feel like this method is more appropriate. But in this case, this one fits just fine. Either one's totally cool. Either one I won't yell at you for doing. This way's easier to flowchart. So, we will probably hit a time when it's most appropriate to use a break, and if so, I'll try to lay out some rules of when to do it. All right, that working for everybody? I didn't actually test this third one. Do it again. Yeah, no. What's up? Do it again. Yeah, no. Okay. Two ways of writing the same loop. Both of them correct. Generally, when I use a break, is when this choice here is not just a repeat, but it's got several different options. Do you wish to 1, print your document, 2, save your document, 3, exit? And if this thing is doing more than one thing, to me it makes sense for exit to be a break statement to bail out of it. So we will get to using it, but we're not going to do that today. Okay, so we're going to do an assignment, well, an in class, that relies on loops and if-elifs. And in conjunction with my usual silly examples, this one's going to determine whether we want to wear a tank top outside. We need some pseudocode because this is a really complex decision here to make. Our pseudocode always starts with a start. We're going to need some way of getting the temperature. Input temp. Now rules for tank tops. Let's go ahead and list them up in a comment up here at the very top. Greater than 120 degrees. Too hot, just stay inside. Less than 40 degrees. Too cold. Wear a coat. Otherwise, it's tank tops time. This doesn't have to compile, so I didn't really have to make it comments. So we input the temperature, and then we're going to check the first case. If
You went to the gym this week.
yeah, if we're warm because we have a fever and we don't care how cold it is, no, we'll just go with this. If temperature is greater than 120, output, although I don't mind the word print inside pseudocode, output, too hot, just stay inside. That's assuming we all have air conditioning. Else, if, although, here's where I kind of go, I don't know if I want to make my pseudocode look like Python or not. Other languages actually use the word else if. Python uses elif. When you write your code, you're going to have to make it elif. I'm going to go with elif just because if I make it else if, then I'll probably make my Python code say the same thing, and it's going to look okay, but it's going to be a syntax error. So I guess I'll just go with elif. Elif, the temperature is less than 40, output Too cold. Wear a coat. And then lastly, if none of those conditions is true, we're going to output just right for tank tops. Personally, I wouldn't wear them at 40, but then again, I never wear them anyway, so here we go. That's our program. It doesn't have a way out. It doesn't have a loop. We could fix that and add the loop now, or we could implement the flowchart like this and then add the loop. We could write this in the Python and then go back and do the flowchart like some people like to do. Pondering this. Let's go ahead and implement the loop here. So if we're going to do this like we did the other one, I hope I didn't delete it. No, wait, it's in Notepad. No, it's not. Where did I have my examples of my loops? I may have lost them. Aha. Here we had to initialize our loop variable. In some ways, this is what is known as a flag. And the flag lets the program decide whether it should keep running or whether it should stop running. We have to initialize our flag if we're going to use that as our while loop. Meaning that if this wasn't here, then it wouldn't compile. Why? Because it doesn't know what A is. Now in this case it actually does because we used A up here. But ignoring that, if we didn't have all this stuff, then the code would not work. It may look like it's about to work, but when I run it, it blows up. A is not defined. So we need to declare a variable. What I want it to do is to work like this. What is the temp? You don't have to type this. They'll answer. They're going to say it's 100 degrees. We're going to print something, and then it's going to say, do you wish to repeat? YN. So we need a flag to store that variable, do you wish to repeat? And A is a stupid name for a flag because it doesn't mean anything. So let's go back here. After start, we're going to declare our flag, and we're going to say repeat is equal to Y. You could instead make them type the whole word yes or capital Y or whatever, but I'm going to go with lowercase y. It's fastest to type for me. And then we need our while loop with our condition. Our condition is as long as that variable has the value y in it. Now, according to our flowchart rules, we should always use the word set in front of an assignment. I don't usually remember to do that. But then when you don't do it, I send you a comment, so I need to remember to do it too. Okay. We're going to have to indent everything under that while loop that we want to repeat, because that's the way while loops work. Whatever is indented underneath it gets repeated over and over. So highlight all that stuff. Not the stop statement. We don't want to indent stop, but the rest of it. Highlight it all and either choose format, indent, or if you're not using Python to write this stuff, then just hit the tab key. If you were using Notepad, it's going to erase it all, undo that, and do each line individually. Okay. Now we're good, but we need to ask them. So unindent after else, line this up with the rest of them. And then do repeat is equal. Wait. Erase all that. Let's output some message. Output. Do you wish to repeat? Y/N. And then input Y. Input repeat. And then just so that my flowchart doesn't look like it's kind of hanging off a cliff, I'm going to add, not flowchart, pseudocode, I'm going to output the word done. And that needs to be unindented because it needs to line up with the word while, because we're not going to print that word out until we leave the word. We leave the loop. So that's what our pseudocode looks like. It's going to be real easy to turn this into Python. We pretty much already know when you do an input, you do 3 steps. You do a print, you get the input in, you convert it. Here we've already specified what the print's going to be, and since we're just inputting a word rather than a number, we're not going to even have to convert it afterwards. And the rest of this, about the only difference we're going to have to make is take the word set off and add some colons. So it's going to be real easy to turn this to Python code. In general, when you're thinking logic out to yourself, you don't usually need to do both pseudocode and a flowchart. But you may need to do a flowchart in order to show it to a customer to explain some logic, because they're not going to understand whiles and sets and stuff like that. They can understand flowcharts better since it's visual. So let's draw a flowchart to match. Now, if you can't log into Lucidchart, you were having problems with that on Tuesday, is that correct?
I checked it again, and unfortunately it won't let me log in.
Okay, go back into our news, scroll all the way down to the Lucidchart link, and just make yourself a new account.
Okay.
You could put your home email address or something in there. All right, now if I was a Brad, I'd say, okay, go draw the flowchart, and I'd go get some coffee. We're not quite there yet. I kind of need my text as a reminder. So I'm going to take my pseudocode, shrink it, put it in another notepad window, or in the same one, but reduce the font size so I can make it as small as possible. Is that a serious error? No. Okay. There we go. Hide that on the side. Y'all can't read it, but I can at least use it as my cheat sheet. All right. What do they all begin with? Start. What was the next thing in our pseudocode? Yeah, so we have a set. What are sets? Those aren't input-outputs. Unfortunately, data is called input-out, or they share the same block, because it means data I/O, which they put in lower letters down there. So we want a process block. Anything mathematical or assigning a value is done in a square, including sets like that. Now we don't have to put the word set in our flowchart, but we could. Doesn't break it. Set repeat equal to y. Now remember that in computerese, a single equal means assign the value, and a double equal means compare the value. All right, as usual, I'm going to try to fit everything on one screen, and it's going to involve some contortions. Alrighty, then after our set statement was our while. Whiles are done just like ifs. You don't have to put the word while in there, but I think it's a good practice. A lot of textbooks don't, but we're better than the textbooks. While repeat is equal to y. If you have to hit Control-Enter somewhere in there to embed, character turn to make the text look good, go for it. or if you just feel like stretching the diamond out to fit the text, that's also cool. Everything that's indented under the while statement in our pseudocode is going to be off in the yes direction. Now really, you could draw the yes line going any way you want to. And one student yesterday drew all the yes stuff directly underneath it, and it actually made a better looking flowchart. And I'm going to go ahead and go off to the right, and my general thinking on that is anywhere my flowchart goes off to the right, I'm going to indent in my final program. So now we need to input the temperature. That's a data block. That's a quadrilateral. Input temp. I am dragging this up a little space just because I'm going to need all the space I can get. You don't have to do that. Doesn't hurt if you do. I just wish I didn't have to. Okay. After the input, we start our if statements. If temperature is greater than 120. If that's true, we want to run off and do something. We want to print something. So yes, and printing is a data block as well, quadrilateral. Print. Too hot. Stay inside. I'm going to go in front of the word stay, hit Control Enter just to make it all pretty. Now I'm going to leave this for now. And the only reason I'm leaving it now is I know that this is an if-else-if structure. And if we remember our cookbook, if-else-ifs don't immediately go back to the next statement. Instead, they all kind of join later at the bottom. So I'm going to leave a dead end for now. Now, dead ends are illegal in flowcharts, so I have to come back and fix that. But not right now. Just like if we're going to paint our happy trees, we don't have to paint them all before we add some happy clouds. Let's do an if statement here. Else, or elif, temperature is less than 40. Print, too cold, wear a coat. You know what, I think I can remember the rest of the pseudocode now. Lastly, if neither one of these ifs were true, we have a default case of saying, great, it's perfect weather. Print. Perfect weather for a tank. Dot.
I thought you put print statements and processes. Why is the first one in parallel?
I goofed that one. That one's in the wrong shape. I'm sorry, is that what you were pointing out?
Yeah.
Yep. I goofed that one. I apologize for everybody who followed my ignorant lead here. I'm going to right click and do change shape and make it a data block. See there, I'd count points off for you, and I'm doing the same thing. What a hypocrite. Here we go.
It happens.
Actually, I love it when students catch the problems like that because it means you're paying attention and thinking about it. All right, now we have all three mutually exclusive conditions. They need to match, they need to rejoin somehow. So I'm just going to put a circle It doesn't have to have the letter A in it, so I'm going to take that out. And then I have to draw a whole bunch of lines that go to that circle. From that one, from that one, and from that one. Now this looks dumb because it's intersecting that other one, so I'm going to drag that line out so that it no longer intersects it. And you can spend hours trying to make these look perfect. I'm not doing that, but there we go. That's the proper if, else structure. Now, like I said, I like to personally change the word no, if it's just an else rather than an elif, to the word else. You don't got to do that. I think it makes it easier to understand. But to give in to peer pressure, I will also put the word no there sometimes. But I'm just going to leave this else. All right, what's the last thing we do here? We still have something else in our pseudocode that is indented under the while.
I forgot your ending quote, I think, after perfect weather will take.
That's true. That's a syntax error. There's also a logical problem kind of here. Well, for one thing, we're not drawing a line back up to repeat. But we're not ready to repeat because what was the stuff after the if-else ifs? Yeah, we don't have this last thing down here where we output do you wish to repeat, and then we get some input. So output, do you wish to repeat, y/n. And I think I may make an executive decision that it's okay to put an output and an input in the same block. So what I'm going to do is I'm going to hit Control Enter and do maybe 2 Control Enters and then do input Y. Now don't tell the Flowchart police I did that. Why do I think it's okay to do that? Because this input statement is really a print and followed by an input. We just didn't say what the print message was. Wouldn't be a bad idea to do that. Here we are specifying what the print message is. Why didn't I use the word print rather than output? I'm going to go back over here and change that to print. All right, now that we have our input, we can loop back up to the while statement. So lastly, after the while, there was a print done and then a stop. Now, if I was drawing this for my own personal use or to put in a book, I'll be right there. I would draw a straight line all the way down here, but I don't like making us have to scroll around when I'm doing it on the screen, so I'm just going to kind of put my print statement off to the side here. Print, done, and then I'm going to draw a no line to that, and then put my stop underneath that. All right, anybody else want me to look at their flowchart, or are we going to proceed into coding it? Another thing you can do, like any other graphics program, it has an align feature. If you wanted all these shapes to be lined up perfectly vertically, you just select them all. You right click and choose align objects according to their center.
How do I do that in Visio?
Good question. I am really not familiar with Visio. If you want me to find it out, then I'll fire up Visio after class.
I'll Google it.
So I'm going to save this. I hit Control S, or you go into the file save, call it tank top, and then do download as. Just make it a PDF, save it somewhere. Then later on you'll have to go find it. There's already a Dropbox for it, so if you want to upload this and your pseudocode, you can. Alrighty, let's turn this into a program. Launch idle, do file new.
Can we call this tank top?
Yeah, let's call this tanktop.py. And the pseudocode, we could have called it tanktop.txt or whatever. Alrighty. I'm going to put my name up here. I'm going to pretend that I am
Oh, I said this
Vlad the
top time.
Coder. February 16. Tank top calculator. I'm going to be awesomely professional and document those rules again. Rules. Greater than 120 equals too hot. Less than 40 is equal to too cold. And otherwise, just right. Alrighty, now there is no start command. I would like to have the pseudocode sitting over here in a corner to remind me of what I'm doing. Either that or the flowchart, but I think the pseudocode will be adequate enough. I don't know, might be fun to code from the flowchart, but I'm going to shrink it down. Alrighty, there is no start. If you felt like putting a start, you could in a comment. Now we need to set, but there is no set command. So we just do repeat is equal to, quote, y, end quote. Then we have a while. While repeat is equal to y, colon. Why do we need the colon? Because we're going to start indenting. Every time you start indenting, there better be a colon on the previous line. Now we need to do all that stuff that's inside the loop, everything that's off to the right of the while loop. So we need to input the temperature. That's always a three-step process, or at least a two-step process, where we use input and then the words inside the input command. I'm going to do a three-step process. Print, what is the temperature? Now, unlike our pseudocode and flowchart, we can't type input y. I'm sorry that the syntax is backwards when we're actually doing this. It's y is equal to input. Then let's convert it to a float. Why am I using y? Where did that come from? Temp is equal to input. Thank you for catching that. Temp is equal to float temp. Now let's start our series of if statements. If temperature greater than 120, colon, tab, print, too hot, just stay inside. elif, because there is no else if option in this language, unlike some others. If the temperature is less than 40, colon, print too cold, wear a coat, and then lined up with the if and the elif is our final default clause, else colon, print. Perfect. Wear the tank top. Now we need to ask, print, do you wish to repeat or continue? Do you wish to repeat y/n? And then y is equal to input, but there's no conversion involved this time. Yeah, we could have made them say, do you wish to repeat 1 equals yes, 2 equals no, but we can use letters just as good as we can use numbers. And if we use letters, we don't need to do any conversions. Then we stop indenting completely so that we can put our done message or goodbye message. And even though we didn't put it on the flowchart, we could tack on a final input that says press enter. Just that's enough. That way if you double clicked on the script, it would run it and it would keep the screen open until they pressed enter or click the close box.
Professor Thompson,
Yes, sir.
for that last question, do you wish to repeat? Should the input be equal to repeat, not why?
Why am I using that? Thank you. I'm going to go stand in the corner. Repeat equals input. I changed that line. Thank you very much. If I was Homer Simpson, I'd say don't. All right, try it out. Save it, run it. Remember to try all three options. Too cold, too hot, just right. 0, it's too cold. Yes, I want to repeat. 200 degrees outside. Man, global warming. That's too hot. Yes, I want to repeat. 30, too cold. I actually meant to choose something that would make it say just right. 70. Perfect. And now I'm tired of this incredibly useful program, so I type no and it's done. Press enter. So this one's very similar to what we just did. Very, very similar. The homework. This is a Coast Guard recruitment tool. We need to figure out if the person is eligible to enlist in the Coast Guard or not. And you know those Coast Guard recruiters are incredibly, persistent. They'll just run around the block chasing you in their boats. So write the pseudocode for a program that determines if a person is too young or too old to enlist in the Coast Guard. The rules are that you have to be between 17 and 32. This is actually legit, but if you are 17, you have to have parents' permission. And if you're older than 29, you have to be going to a certain school. But anyways, we're not going to put all that stuff in there. So if a person is 16, they're too young, and if they're 33, they're too old. This is a demonstration of how it should look. It doesn't have to look exactly like this, but it's the concept. What is the person's age? 9. They are too young to join the Coast Guard. Well, that poor Timmy, he really wanted to join. What is the person's age? 49. All right, Grandpa, go back home. You're too old. Then the user runs the program again. And by the way, when you say these sarcastic things, if you ever actually encode those sarcastic things, meaning to go back and change them, there's always a possibility that you won't, and you'll wind up mailing out things to customers that have abuse and insults and stuff like that.
It's
Don't.
fine.
Yeah, it happens.
Have you done that?
No, but I read a,
It's like-
I read a particularly egregious one about Wells Fargo doing that, and like 10,000 customers getting an insulting letter. Anyways, then the user runs the program once more. What is the person's age? 20. Perfect to join the Coast Guard. Now, just looking at this, it'd be better if it looped, huh? Rather than have to rerun it over and over. So I'm going to ask y'all to make it loop. Now, you can get full credit for doing the assignment without the loop, but we're awesome. We've already just established that. Extra credit for making the program loop. So that's homework 4. So do the pseudocode. Guess what 5 is? Draw the flowchart. Guess what 6 is? Write the Python program. So this is actually 3 assignments. It's 300 points just for doing what took us 45 minutes in class. So
When's 6 due?
they're all going to be due the same day, Wednesday of next week.